Assalamualaikum warahmatullahi wabarakatuh and hello. So today I'm from group 6. I'm going to present our group project. The title of our group project is Application of Parabola and Hyperbola. So this is our team members, Mable, Xuewei, SITI NABILA and me, SYIRA. Now I'm going to talk about the introduction, background study. So a curve can be defined as the plane algebraic curve of degree 2 because it contains a set of points that use a switch quadratic equation in two variables. The next section that we choose is parabola and hyperbola. So parabola is a U-shape at a stretched geometric plane. So according to mathematicians, they discovered the formula of y equal to x squared on the xy axis. In real life, parabolas can be found in nature, theme parks and buildings. As an example, when riding a roller coaster, the rising and falling path that the roller coaster takes is actually a parabolic track. So for hyperbola, it's basically the same as parabola, but it is cut steeper from the edge of the cone. The intersect of hyperbola does not intersect with the asymptotes, and the distance is small at a great distance from center. So hyperbola can be seen in our real life too, in our essential things or orbit of a spacecraft. For example, the easiest essential things that has a hyperbola shape is glasses. Our key concept is to discover the height or dimensions of an architectural structure, such as the bridge or on buildings. So the equation of parabola and hyperbola is used to solve the application on connect section. Based on the two applications that we are discussed, problem 1 use the application of parabola and problem 2 use the application of hyperbola. For objective, we have two objectives. The first objective is to understand how conic section perfectly imply in real life, and the second objective is to understand how should we use the equation of conic sections on various shapes to solve real-time problems. So for the first objective, we will discuss in this project how common people use the shape of the parabola to solve the shape structure of bridges, and the way how the hyperbola shape applies the building structures that we see in real life. For the second objective, we discuss on by using the formula of the parabola to find the height of parabolic bridge. On the other hand, we can also understand how to use the information of building structure in terms of height or radius to form a hyperbolic equation. There are two types of methodology that we use, which is quantitative and qualitative method. So for quantitative method, we divide it by two, collections on applications and analyzing and discussion. For collections on applications, the application problems that we found were taken from internet source. So for application number 1, which is suspension bridge, which we found in Ray A. Mumphrey's slides, the title is Bridge Problems and Design. For application number 2, which is the hyperbola building infrastructure, the idea was from the research made by Nurul Izzam Mansur from UTM, but we only changed the tower from Cooling Tower to Tabuhachi Tower. And for analyzing and discussion, first we discuss the subtopic that we want, we do a meetings, we present what we found in the internet, we analyze and taking concern of all the pros and cons, and then we choose the best two application problems, which is the subtopic of connect section, to continue with our group project. So for the second method is qualitative method, which is calculation and substitution. So for problem number 1, we use the equation below, which is about finding the height of the cable route from the center of the bridge. So all the information we gathered and then substitute into the equation to get the value of P. For problem number 2 is the equation of hyperbola, which is about finding the sides A and B of a cooling water and solving the equation by using the substitution method.
My name is Xuewei, entry number 279569. Now I would like to present the application of parabola in suspension bridge. Malaysia has around 6,647 units with 10 types of bridge. However, beam bridge is the bridge most used in Malaysia. As we know, a lot of bridge problems in Malaysia, for example, damage at the underside of a beam in Kuala Lumpur, flexure and shear problems in the beam. So we can say that beam bridge have a lot of disadvantages. First, it must be large, since the forces acting on a beam bridge are greater than the load. Second, it can accommodate large vehicles because its span has a limit. And the last, it didn't have a support, so that it's only suitable for short distances. Hence, we can choose suspension bridge to replace beam bridge. Suspension bridge with parabolic spans on both sides. The sustainability depends on its deck. It can be created sturdy enough to accommodate freight trains, although they are always built for car traffic. Suspension bridge have a lot of advantages. First, it able to travel vehicles for enormous distances. Second, it can span anywhere from 2,000 to 13,000 feet. Third, the cost of building suspension bridge is not expensive. Fourth, it is easier to maintain. And the last, it is affordable, means that it can be built anywhere as long as the place has a support tower or anchorage. So we can use the theory of parabola applied in suspension bridge in our real life. This is our problem statement. The cables of a suspended deck suspension bridge are in the shape of a parabola. The pillars supporting the cable are 600 feet apart and rise 90 feet above the road. The lowest height of the cable, which is 10 feet above the road, is reached halfway between the pillars. So what is the height of the cable from the road at a point 150 feet from the center of the bridge? For solution and analysis, first we let x-axis equal to road and y-axis equal to location halfway between the pillars. So we need an equation for the parabola to find the point 150 and y on the parabola. The coordinate of pillar is 390, the coordinate of vertex is 0 and 10. So we can use the theory of parabola with the equation of parabola is x minus h squared equal to 4p subtract with y minus k. So after substitute the value, we found that the equation of the cables is x squared equal to 1125 subtract with y minus 10. So after substitute the point 150 and y to the equation, we found that y equal to 30 feet. In conclusion, the height of the cable from the road at a point of 150 feet from the center of the bridge is 30 feet.
Hi, my name is SITI NABILA binti ABDUL HALIM, Geometry 281-283. Okay, the other examples of the application of the hyperbola is Tabuhachi Tower. Tabuhachi Tower is a one-of-a-kind style representation because it was conceptually designed with the intention of incorporating Islamic and Malay influence into modernism. Modern style is emphasized in its orientation, which is symmetrical balance and contains equalized building elements. This 152 cm tall building consists of 38 floors, mainly for the office and car park area. The framework is made up of 5 columns that represent the 5 pillars of Islam, which is Shahada, prayer, zakat, fasting, and Hajj. On the other hand, it is also serves as support structure for the building. We get to know that the cooling tower is another structure that resembles the Tabuhachi Tower in design. A cooling tower is a device that rejects waste heat to the atmosphere by cooling a coolant stream, typically a water stream, to a lower temperature. The use of multiple cooling towers is a common means of disposal of waste heat from large power plants. Because of their hyperbolic shapes, these structures can withstand high winds while using less material than other structures of comparable size and strength. In this project, we will use the cooling tower design to find the hyperbolic equation that models the sides because it is straightforward.
My name is Mable Xuewei and my metric number is 279652. Now I will present on the problem statement of the application of hyperbola. The nuclear cooling power plant has the shape of the hyperbola. This shape is more efficient when the function of cooling of power plants. Note that the height of the tower stands 179.6 meters tall, whereas the diameter of the top of the nuclear cooling power plant is 72 meters. The distance between the sides of the towers when they are at their closest is 60 meters apart. Based on the diagram above, suppose that the intersection of the dashed perpendicular lines indicates the center of the hyperbola. Assume that the origin is located at the center of the tower, thus we will use the form of the standard form equation of the horizontal hyperbola. The equation of the hyperbola is x squared over a squared minus y squared over b squared equals to 1, where a squared and b squared represents the sides of the cooling tower, which are also the branches of the hyperbola form. First, to find a square, the length of the transverse axis is equal to the both sides of the cooling tower, and this length of the distance represents the closest distance between the two sides of the tower. The length of the transverse axis equals to 2a. Based on the figure, the length between the two sides of the tower is 60 meters. We can solve this by using the length of the transverse axis 2a. By doing this, we can equate a squared equals to 900 meters. Next, to find the b square, Use the equation of the horizontal hyperbola and then substitute the value of x and y into the equation. Note that the x position is the radius on top of the cooling tower, and the y position represents the height that divides the tower into half. Thus, the point of xy value is 36 and 79.6. By using the horizontal hyperbola equation, we will equate b squared equals to y squared divided by x squared of a squared minus 1. By substituting a square, x and y values, the b answer is 14,400.3636. Thus, by substituting the a values and b value, the hyperbolic equation that represents the two sides of the tower is shown. As a conclusion, the application of the parabola and hyperbola has been applied in real life, which can be seen in the nature of works like bridges and buildings. The equation of parabola and hyperbola has been used as a key concept in architecture structure, which refers to the height of the structure and the dimensions of the structure. The equations of parabola and hyperbola help in the architecture to find the right measurement and to make balanced and safe structures. That is all from us. Thank you.